Currently we are working on task J, and this is our initial setup. We have 3 sensor neurons, torso, back leg and front leg. We have 2 motor neurons which are connected to torso back leg joint and torso front leg joint. We also have 2 synapses here. The first one connects the torso sensor with torso back leg joint motor neuron, and the other one connects the sensor at back leg with the motor neuron at torso back leg. And the weights of both the synapses are 1.0. Let's try this out. Let's see how our robot behaves with these settings. So I'm just gonna run simulate and let's see. Oh, okay. So it looks like our robot is moving towards the right side of the screen, which is towards the user. Cool. Now let's see what we are trying to do here. It says yada yada yada. Okay, keep going until you find a combination of synapses and synaptic weights that causes the robot to move to the left and away from the viewer. So right now our robot is moving towards the right side of the screen or towards the user. We want the opposite behavior. Cool, so let's try to change these weights. Right now these are positive weights. Let's try them to negatives and let's see how the behavior changes. Okay. Oh, we just moved to left a little bit, but this is it. This is definitely not we want. Not we want. What we want is the robot to move towards the left. Okay, let's try something else then. How about adding more synapses? So far we have 2 synapses here connecting torso and back leg sensors with torso back leg joint motor neuron. What I'll try to do next is let's first change this back to positive values, and then I'll try to create 2 more synapses here. Okay, so the first one, we can keep the source neuron as it is. We want to connect torso with torso front leg, so I'll change the target neuron to 4. And now instead of back leg, I want the front leg to be connected with the motor neuron at torso front leg. So I'll probably change this to 2 and this to 4. Let's keep the weight same and let's see. Okay, the robot is still moving towards the right, but oh, there are some cancelling forces. I guess there are some contradictory forces or torque because we have the same weight in opposite directions. Let's try to now let's try to change the weights a little bit. So instead of 1, what if I change the weights of the first 2 synapses which are connected with torso back leg motor neuron to 0, so that only the front leg is active, the motor neuron at torso front leg is active. Let's try that. I'm going to click on simulate. Let's see. Okay, so now it's not moving towards the right anymore because we have changed the weights of the back leg motor neuron to 0, but it's still not moving towards the left. Okay, what if we change the weights to -1 this time for all 4 of the synapses? Okay, let's try this. I accidentally closed the file. Let's open it again. Generate.py. Here we go. Let's run this, and then I'm gonna run simulate. Okay. Oh no! Wow. Now it is moving towards the left, but still it's a bumpy ride because of those contradictory forces again. I think this robot is going to fall off at some point. Yeah. That's not a pretty ride, but okay. We made some progress. It is moving towards the left now. Uh, we still have the similar weights on both the motor neurons. Let's try to make this weight as 0 because we don't want any force on the back leg motor neuron. We only want the torque to be applied on the front leg motor neuron so that we get the robot to move towards the left side of the screen. Let's see. Cool. Now this is more smooth walk, I'd say, as compared to the previous one. And we got the robot to move towards the left. I think that is what we wanted, right? Let's just try to see for a couple of seconds if it falls. I don't think it will fall. It will fall. This looks like a smooth walk. Yeah, I don't think it's gonna fall. Cool. So I guess this is what we wanted to do.